Today we are going to discuss about chapter 11, refraction through a prism. Refraction through a prism. See, last class we discussed about how refraction through a glass slab. This is a glass slab. We discussed about how refraction takes place in this side. See here, these two sides parallel, here two sides also parallel. This is a glass slab. But now we are going to discuss about refraction through a prism. Refraction through a prism. See here, for a prism, here two bases, one this one and another this, two bases and three rectangular surfaces. This 1, 2 and 3. These are the three refracting surfaces, and this one is the base and this also base. This is a rectangular refracting surface. Now, before going to discuss about refraction through this prism, just we can remember about refraction through a glass slab. See here, this we discussed in the last class. See here, A, B, C, D. Here on light ray incident, here way, and here it is refracted. This is the normal which we draw. Now the refracted ray here, it passes from this optically rare medium to denser medium. So this refracted ray bend or shifted towards the normal, and now this light rays, this we can write as normal M dash. This emerges out. This is the emergent ray, and if we extend this on in this manner, we can see these two are parallel. These two are parallel here. Now these two are parallel but slightly shifted. Now incident ray and emergent ray parallel in this case, but these slightly shifted from its path. That we can see in the case of what is a glass slab, refraction through a glass slab. Now we want to discuss about refraction through a prism. Now see, how is a prism? Prism is a transparent. This prism is a transparent material with how many bases? You can see how many bases here, one up and another one down. These are the two bases. Then how many other rectangular surfaces? This one, 2, 3. This triangular base here also one side, two side, third side. 2. Here also two triangular. That is two triangular base. And this one 2, 3, 4. 4 rectangular side. That means this is a rectangular side, and this one is another one. This one is another. Now 3, 1, 2, 3. 3 rectangular surfaces there that act as refracting surfaces. Here, these two surfaces, when you consider this surface and this surface, between these two surfaces, this one and this one, there is an angle, and that is the angle of the prism. Here also angle of the prism. That means angle between any two these rectangular surface is called angle of the prism, that we used to represent with the angle A. Now we are going to discuss about the refraction. See, this place a rectangular prism with its base on a sheet of paper. Now, let a light ray is allowed to fall this side. And here, two pin. Let it be P, and here it is another pin Q. Suppose this is a drawing board. In that drawing board, we fix a sheet of paper. On it, we place placed this triangular, this glass prism. Then allow to draw its outline with a pencil. Now we draw its outline with a pencil. Then draw a ray. That means draw a straight line to one side. Now here a pin P and Q are two pins. Which are the two pins P and Q? Two pins fixed here. Now by looking on the other side, after placing this prism on this outline, looking on the other side, you fix another two pins in this way. Let me R and S. See, R and S. Now, at first when you going to fix this pin here, look from this side, you can see this R, Q, P. They are in the same line. You can see these three pin now in a line. In that way, you want to fix this on here. And another one here, after that only you want to draw this line. Then another you fix another one pin also, that is S. Now, when you look from this side, after placing this prism here, when you look through this pin, you can see this S, R, P, Q. These are all on a line. This all you can see in a line. Now, this line you extend in this way after taking the prism. And this also in this manner. Now, you get this is the PQ is the incident ray and RS is the emergent ray, and here this when you mark A, B, C. This A is the angle of the prism, and this incident ray is here, in this way is going. This is the emergent ray. Here is on angle, that is the angle of deviation. This is the angle of deviation. And you can draw on perpendicular to this side. And this perpendicular, let it be N and N dash. Angle between this incident and this normal, this is angle of incidence I. And here is coming angle, that means when we join this, you get this is the refractor ray. This is the refractor ray. Now this refractor ray goes through this way. See, here is the angle of refraction. R is the angle of refraction here, and here when we can draw on normal, this is the angle of emergence. Angle of emergence. Now we got these points that you can see in this figure also. See, just I arrange this on. Now see that four pins. You can see when you look here, this on 1, 2, 3, 4. These four pins you can see in a line. Now these four pins, this on 2, 3. You want to look through this pin. Then you can see this and this and this. These all the four pin. Now you can see in a single line. Okay, you can see these four pins in a line. After taking this prism, that means after taking, that means when I look through this pin, these two pins also in the line of this horn. Now these four pins are in a line. After you take, you can see these four pins. If now these four are in a line, no. Now we want to join this path in this way. Now after taking these two pins, you can draw a line like this way, and these two are, then you join. This is the refractor ray. You can get it now from this side. Okay, now see here what are the things? P and S are the two pins which I fixed here. P and Q. Then another R and S, two pins fixed here. But after placing this prism here, when you look, you see these four pins are in a line. these 4 pins are in a line. Why? It is due to the refraction of light in this prism. Now, after joining this, what are the things you want to remember from this? What is actually PQ here? What is PQ? This PQ is the incident ray. Okay? And what is this RS? RS. Emergent ray. And from this PQ, this one is the refractor ray in this. That means this D from this point to here, this is the refractor ray. And I is the what angle I? What is angle of incidence? Angle of incidence. Then this here are, that means this refractor ray and this is normal. Here on angle, this is the angle of refraction. R. What is R? Angle of refraction. Angle of refraction. And here is, that means normal and emergent ray. Then angle E. What it is? Angle of emergence. Angle of emergence. And see, this is the path of the actual incident ray. This is the path of the emergent ray. And in between there is one angle, and that angle D is the angle of deviation. Angle of deviation. But it is an angle of deviation. Then this is the one surface of the prism. This another surface in between there is one angle is coming. That angle A is the angle of the prism. Angle of the prism. Now this is the refraction through the prism. Now this is the refraction through the prism. After drawing we get to this one. When you look through this pin, you can see these 4 pins are in the same line. See, 1, 2, 3, 4. Can you see this 4 pin now in a single line? But after taking, that means when you look through this one, second pin, these 2 are in line, and third one also will come. This fourth one, this 4 pin now you can see through this in a single line. But after taking this prism, you see this line is this way, this line is this way. That means they are not in a line. But why this happened? Because the refraction in the prism that appears in a line. Okay, see, what are the things you want to remember about refraction through a prism? PQ, how we find this? P is a pin and Q is a pin that at first arranged in a line. Then after we place this prism on this outline, then look on the other side of the prism and fix on pin. But that when you fix the third pin, you should remember that third pin, this first, second, that all come in the line. In such a way you want to fix it. Then you want to fix the fourth pin. Now when you are going to fix the fourth pin, you want to see it, this fourth, third, second, first, these all should be in a line. In such a way and you want to fix it. Then you take the prism and complete the diagram. Then what are the things you get here? Then what are the things you want to remember from this? What is PQ? PQ is the incident ray. What is RS? Emergent ray. I is the angle of incidence. R is the angle of refraction. E is the angle of emergence, and D is the angle of minimum deviation. This is the refraction through a glass prism. Now, see how this refraction is happening in when light, that means just white light is passing through this one. For that, we are taking this arrangement. See, this triangular glass prism. You want to keep this triangular glass prism in order to get a narrow beam of light such as sunlight from this to fall on of its side. Then see here we can get somewhat here. See, this is we discussed about how a glass prism refract light rays. Now, dispersion of white light by a glass prism. We know there are two different types of light. One is monochromatic light. Monochromatic light. Second one is composite light. That means monochromatic light means a light composed of only on wavelength. That means here you see yellow light is a monochromatic because there is only one wavelength is there. That means or there is only one colored light, color light. But when a light composed of more than one color, then it is called composite light. So white light is a composite light, but light from a mercury vapor lamp is an example. Light from a mercury lamp is a composite light because it consists of different colors in it and different wavelength also. But monochromatic light, suppose sodium vapor lamp. That means sodium vapor lamp is an example of monochromatic light because it consists of only yellow color. That means a single wavelength light is there. So such a kind of light is monochromatic and another one is composite light. Now we know white light is a composite light. White light is a composite light. Now this light, how dispersion occur in a prism? See, you can observe this dispersion by arranging a prism and in your room and let sunlight allowed to fall. A narrow beam of sunlight is allowed to fall on this prism. It's on of its side. Now, if this is a light from sun, a narrow slit of light is allowed to incident on this surface and arrange a screen on this or arrange the light from the prism part on a white wall or a screen. Now you get a band of color on the screen or the white wall. This band of colors is of the order from first violet, last you get red. So the order of the color is violet, indigo, blue, green, yellow, orange and red. These are the colors which we obtained on the screen. And to remember this all colors of its order, we can take this violet, indigo, blue, green, yellow, orange, red, that is with geo. In this way we can remember the order of the colors and these colors and its order. Here we obtain is called a spectrum of this white light. Spectrum of the white light. Here see this violet is deviated or changed its direction more, and the least deviated color is red. Which color deviated more? That is violet deviated most among these all. and least deviated one is what is red one. This is the way or path of the light. Now the most deviated color is this one, that is violet, and among this least deviated is red. Why this happen in this way? Because we know sunlight is composed of different colors. That means it is a composite light. Now when you observe the wavelength of this violet, it is from 400 to 440 nanometer. Then we say, you know, 1 nanometer is 10 to the power minus 9 meter. And when you consider red, its wavelength is from red, its wavelength range from 620 to 700 nm. That means compared to violet, wavelength of red is more. So here the least wavelength color is violet and most wavelength color is red. When this light passes through a prism, it deviates or take refraction at different rates. That means the angle of deviation when we consider, here the shortest wavelength violet deviated more, and or refraction of this one is more, and here least deviation occur for red. Because of that these colors separated here. Because of that these colors separated when refraction occurs in this prism. Why these colors separated here? Because its angle of refraction is different for different colors. Angle of refraction is different for different colors. Which color is deviated most? Which color? Here violet deviated most, and which one is deviated least? Red deviated least. That you can observe from here. Once again, how this prism refracted white light. How this one is refracted? What is its order? Order of this one: violet, indigo, blue, green, yellow, orange, red. Among these, most deviated violet and least deviated on red. Why this happen? Because wavelength of this violet is least among this, and the wavelength of this one is highest of red, so its deviation is less. Now you want to remember one thing about Newton. Newton is the first scientist who studied about dispersion of white light or dispersion of sunlight in a glass prism. That means you know, a glass prism is like this. When light falls on one of its sides, that separated into different rate, and about that Newton studied at first. That means the dispersion of light. Who studied about it at first? Newton studied. Now see here, when light falls, this separated into, that means refraction takes place at both the surface, and red and violet. Now Newton placed one more prism again on this side. That means at first he placed one prism here, and he placed another prism in this way. Now to get refraction, but he could not get again. It is more separation of the colors. At first he got violet to red. To separate again these colors, he placed one more prism in this manner, but he cannot get any more result. The same one he got. Then what he did means he arranged two prisms in the opposite direction. That means first prism, that means base of the first prism in this way, base. And then he arranged second prism in this manner, that means here base. Then he did this one activity. Now see, first prism this way, he allowed to light light to fall on side of this prism, then he got different colors on this side. Now he arranged the second prism just reverse of the order. Then see here light falls, and then again he got, that means white light on the screen. That means he observed he will get something more, but what he got? He got a white light on the prism. That means by arranging two prisms in the opposite direction, at first sunlight split into different colors. Second prisms combines that different colors again into white light. From this he got idea is white light is composed of different colors. White light is composed of different colors. Which are the colors here? That means violet to red, violet, indigo, blue, green, yellow, orange, red. That means how many colors are here? How many? 1, 2, 3, 4, 5, 6, 7. That means 7 colors. Now, by combining these 7 colors, this prism, that means the second prism combined these colors, 7 colors, and again got what white light. From this, what he concluded, what Newton concluded, that means white light is composed of 7 colors, and by combining that 7 colors, we can get again white light. That is the observation of Isaac Newton. Now we discussed about how refraction that happens in a prism. What is incident ray, what is emergent ray, and refractor ray, angle of incidence, angle of refraction, angle of emergence, angle of the prism, and deviation, angle of deviation. They are the things. And what is actually spectrum of white light? Which is the spectrum of white light? Spectrum of white light is the colors from which to which? That means violet to red. All colors in the order from violet to red, which you obtained on the screen. That is called the spectrum of the white light. Now, the most spectacular on the spectrum which you see in the sky is the rainbow. Now we can discuss about a rainbow. First of all, you want to know about how rainbow is formed. Rainbow is formed due to the dispersion. How it is formed? Dispersion. Dispersion of, that means just after rain, after the rain shower, that means atmosphere is filled with droplets of water. In these droplets of water, when sunlight falls, there will happen dispersion. There will happen dispersion. In that way, we used to see a rainbow. That means a rainbow is always used to see just opposite to the sun. Where we used to see opposite to the sun. That means if the sun is in the east, where you can see rainbow? West. That means if the sun, where is the sun? Position of the sun is in the east. If it is in the east, where we can see the rainbow, we can see it in the west. That means just opposite. That means in the morning, if you see rainbow, that will be, that means in the morning, sun is in the east, then rainbow you will see where it is in the west. Suppose if you see rainbow in the evening, then evening, that means sun, where it is at west, then you see rainbow in the where you can see, that will be in the east. That means whatever is the position of the sun, just opposite we can see the rainbow. But at the noon we cannot see rainbow because at the noon time sun is above our head. So where it want to form on the earth, that we cannot see in the noon time, because just opposite of the sun we can see rainbow. Now we want to know how that rainbow is occurred. See, just after a rain shower, that means it is filled with droplets of water. This is one of the droplet of water. This is one of the droplet of water. In this sunlight is falling. This is the sunlight. Okay. Here the sunlight, see, at first there is a refraction. When the light refracted, that means when light, which light is, sunlight is a composite, that means a white light. When it is refracted, which color deviated more? We know, that means violet. Which color deviated least? Red. Okay, now here is on refraction. Now actually rainwater or water is transparent, so it must pass through this one, but that does not happen here. It here, that means internally reflected this way. This internally reflected. Now this light, at first there is some refraction, then what happens? There is internal refraction, internally reflected. Then again there is one more refraction, this way. So this color red, here you can see this is a violet. Now this way is the rainbow form. That means here is a refraction. That means it bend towards to us, so it little bit downwards. So see, this will come in this way. That means you can get upside red, downside violet. In this way we can see the rainbow. Here what are the things happening in these droplets? On refraction, then internal refraction, again on refraction. Due to this refraction and internal reflection, due to this refraction and internal reflection, what we get, rainbow is getting. Okay, rainbow is getting in this manner. Now see, when you see different colors, you can see as this way: violet, indigo blue, green, yellow, orange, red. But we cannot separate these colors very clearly. But inner side of the rainbow, that is when you observe the rainbow, that is in the form of an arc. Its inner side is violet, inner edge we will get as violet, and outer edge we get which color? Red in color is observed there. Now we discuss about how a rainbow is formed. What is the reason to form rainbow? It is due to dispersion. First of all, you want to know about why or how rainbow is formed. The reason is dispersion. When does we can see rainbow? Just after or just before the rain also we can see. Why? Because at that time atmosphere is filled with droplets of water. Where you can see rainbow? Just opposite the sun. In the morning, sun is at the east. Then where does the rainbow? Rainbow is the west. In this way you can find out. And what are the things happening in a rain droplet? In a rain droplet, that means what are the things? Refraction, internal reflection, refraction. Due to this, we get different colors. And usually we see a rainbow in the form of an arc. And its inner edge, which color is coming? Violet. Outer edge, which is red. Why this color is coming in this way? Our separated, that is each color makes different angles with our eye line. Because of that we get different colors separated here. And if we observe this rainbow from an aeroplane, then that we can see in the form of a circular shape. That means we can see upper and lower side of the rainbow at that time. Now see, we discussed about what are the things. First of all, refraction in a prism. Okay, prism is what actually? Prism is a transparent medium or material with two bases. 1, 2. These two bases are which shape? Triangular shape. How many refracting surfaces? 1, 2 and 3. Okay, 3. What is the shape of that one? That is a rectangular shape because there is 4 sides. And any two refracting surface, when we consider there is these two refracting surfaces are oblique, so there is an angle in between them, and that is the angle. And refraction that we find out through an activity, how we got it, this incident ray, okay, PQ we can take as this refractor ray, and PQ, and this emergent ray RS. Now this is the angle of incidence and this is the angle of refraction. Here when we draw on normal we get angle of emergence. This is the angle of the prism. Okay, and after that we discuss about dispersion in a prism. When white light passes through a prism, it is split up into different colors. Okay, which are the colors we obtained? The colors we obtained from violet to red. Violet to red. Why these colors separated there? Because each of the colors is refractor. Each of the color are refracted at a different rate. Among that, most deviated one is violet because shortest wavelength among these, and least deviated one is red because the highest wavelength among these. And then we come to know about the spectrum. Then we come to spectrum. Spectrum is what is the colors of the order which we obtained from violet to red. Violet to red, that order of colors is called a spectrum of the light. Here it is a white light. Then we discuss about Isaac Newton's findings. Newton's finding. Newton was the first who did the experiment to find the dispersion. First to find the experiment to find dispersion. At first he got 7 colors. To split again that colors, he placed one more prism in this way, but actually he succeeded in that case. Yes or no? Second prism also placed in this way to separate these 7 colors again, but he cannot split again it more. Then what he did there? He placed another prism. Then he placed another prism just opposite to this one. Okay. Now if the white light is passing through this one, that is splitted in this manner, then to second prism, and that second prism again combines, he got white light. That means he can combine. He combined these colors again. That means from this activity or experiment, he concluded that this white light is composed of different colors. White light is composed of different colors, and that we can split, and by combining that colors again we'll get white light. That is the conclusion. And also he proved this, he made one more things, Newton's color disc. That is a circular disc he made. In that he painted 7 colors. That means in this way: violet, indigo, blue, green, yellow, orange, red, in the same order as we got in this spectrum of white light. Then he rotated at the first. He showed this surface at different colors. When he rotated this on at a very high speed, he got a white surface. That means comparing these all colors, again getting white light. He proved in this way also again this idea. Now we want to know one more point, that is about a rainbow. What is the reason to form rainbow? Rainbow is formed due to which process? The phenomenon called dispersion. What is actually dispersion? Dispersion is the splitting up of white light into its composite colors. Dispersion is the splitting up of white light into its composite colors. This is the reason also to form a rainbow. Now, how we got a rainbow in a rain droplet? That means just after a rain shower, the atmosphere is filled with a million droplets of water. Among that one droplet we consider, that means or when we consider this one droplet, what are the things happening there? That means sunlight is incident there. Okay, and this one is at first there is what happened? There is on refraction here. Here on refraction, this color is red, this color is violet. This on internal reflection, and this way is coming out. Then this red and violet. Okay, this way we get a rainbow. That means on two refraction and on internal reflection is happening in this case. In the case of a rainbow. That means when we observe rainbow, it forms in the form of an arc, and its outer edge is what is outer edge is red and inner edge is violet. This is also here happening because angle made to our eye line, and the center of the rainbow is different. Violet is somewhat about 40.8 and red is 42 point something. That is the reason for this happening. Okay. Okay, with these all things, we can conclude today's class. That means you want to remember refraction through glass, how rainbow is forming, what is spectrum of light, and also what is dispersion. Okay.